Yeah. Show that energy must exceed minimum value of the potential for every normalizable solution to the time independent Schrodinger equation. What is the classical analog to this statement? Okay, he's writing this one again, d square psi by dx square. Again, he gave this one. Okay, he gave some hint also. He gave hint, if E is less than V minimum, then psi and its second derivative always have the same sign, and argue that such function cannot be normalized. Okay, now you should need some idea about maxima minima concept here. Okay, now look at here. If E is less than V minimum, then what will happen? V of x minus E is positive. Am I right? So can I say like this? So it is positive. If this is positive, then what will happen here is d square psi by dx square is equal to 2m by h bar square into V of x minus E, some positive quantity, into psi. Okay, this is positive now, then, isn't it? This is positive quantity. Then psi and its second derivative will have the same sign. That's what he is arguing. Why this cannot happen? Okay, that we have to check here. Why again psi and its second derivative cannot have same? What would happen if psi and its second derivative have the same sign? Okay, now look at here. Suppose if wave function is negative, let me take some arbitrary wave function. Okay, if wave function is negative, okay, then that wave function should exist somewhere here. Okay, suppose this is positive axis, this is negative axis, this is x here. Okay, then wave function should exist somewhere here, isn't it? Now look at here, its second derivative is also negative, means it should be a maxima, it should have a maxima. Am I right? Again, second derivative is negative, means its slope should decrease. Am I right? So then what it should have, again, if a wave function is negative, it should have a maxima. Value of the wave function is negative, and again its second derivative should be also negative. That means it should have a maxima. Once you have a maxima like this, look at here, again it will extend here. Am I right? This kind of curve will extend here, and area under the curve, or if you take mod psi square, again if you integrate mod psi square from minus infinity to plus infinity, that will tend to infinity, isn't it? Again, if suppose wave function is positive, okay, if suppose wave function is positive, its second derivative is also positive. If second derivative is positive, that's a condition for minima. Wave function is positive, value of the function is positive, and its second derivative is also positive, means that should be a condition for minima. And if you have this kind of curve, obviously that curve will diverge like this, isn't it? There should be no discontinuity in the wave function, because it's a differential equation, second order differential equation. Second derivative exists, means psi should be continuous. Am I right? And its first derivative should be also continuous. Am I right? We are writing second derivative equal to psi, mean again a continuity of the wave function should hold always. Isn't it? It's a kind of differential equation solution. So that's why what we can say here is, if wave function is positive, okay, and its second derivative is also positive when energy is less than V minimum. If wave function is negative, its second derivative is also negative. Second derivative positive means, so this is the condition, d square psi by dx square greater than 0. That's a condition for minimum. Okay, so d square psi by dx square, that is negative, that is condition for maximum. Okay, again this kind of curve will always diverge, area under the curve, or this mod psi square dx will always diverge. So that's why energy must exceed minimum value of the potential. Okay, that is the first idea. And classical analogy is, if energy less than V minimum, okay, if energy is less than potential energy, what is the condition? Kinetic energy should be negative. Right? That cannot happen classically, usually. But quantum mechanically, we are thinking about all possibilities, isn't it? So that's why energy must exceed minimum value of the potential. That is the rule that we take. Let me try to apply this one, because unless you apply this one, you will not remember, isn't it? Now suppose if you take Dirac delta barrier, okay, if you take Dirac delta barrier as a potential, V of x is equal to some alpha into delta of x, where alpha is positive. We call this one as Dirac delta barrier. Now I'm going to ask the question. So can you try to answer? How many bound states that this allows? how many bound state that this kind of potential allows. And again, let me give one more potential. Dirac delta well. We call this one as Dirac delta barrier. We call this one as Dirac delta well. Is that okay? V of x is equal to minus alpha into delta of x. Quickly, where alpha is positive. How many bound state that this allows? Again, you should know what is the bound state then. If particle if particle's energy is less than potential at positive infinity as well as negative infinity, then particle will stuck in some region, then we call it as a bound state, isn't it? Again, your energy should be less than potential at minus infinity and potential at plus infinity, then we call it as bound state. That means particle cannot escape to minus infinity or plus infinity. Okay, we call that the situation of bound state. Yeah, you just read the Griffiths. I think he mentioned much more idea about this one. Now, how many bound state that this allows? How many bound state that this one allows? Quickly, anyone? Again, energy should exceed minimum value of the potential. What is the minimum value of the potential here? In this case, what is the minimum value of the potential? Yeah, speak out. Anyone? V of x is equal to, that is infinity when x equal to 0, that is 0 otherwise. What is the minimum value?
0.
0. Minimum value of the potential is 0. Your energy should be greater than minimum value of the potential. Am I right? Energy must exceed minimum value of the potential. Energy should be somewhere here. Energy should be greater than 0. In this case, energy less than 0 is not at all allowed. Okay. In case of Dirac delta barrier, we call this one as barrier because again it's some wall kind of structure. Am I right? It's a Dirac delta barrier. It is Dirac function well. Is that okay? Now, in case of Dirac delta barrier, only scattering state is allowed, E greater than 0. If E is greater than 0, look at here, again that means energy is greater than potential at minus infinity as well as potential at plus infinity. Particle can escape. Particle can tunnel also. Suppose if you shoot the particle, it can tunnel also. You can derive some transmission coefficient and all, but it will escape. It will not be stuck in some region. So that's why this allows only scattering state. Okay, here also scattering state is possible. Why can't? Again, energy can be greater than 0. Why not? That's also possibility. Then also particle can escape at minus infinity or plus infinity. But energy less than 0 is also possibility. Why? Why? What is the minimum value of the potential? Hmm.
Negative infinity.
Minus infinity, isn't it? 0 otherwise. That's why energy less than 0, that kind of state is possible. If energy less than 0, that means energy is less than potential at plus infinity and potential at plus minus infinity. Why? Potential at plus infinity is 0, isn't it? Potential at minus infinity is also 0. So that's why E is less than 0. We call this as bound state. That is possible. Bound state is possible. How many bound state? Again, you need to solve. So this one allows only scattering state. This one allows both scattering state as well as bound state. This is scattering state. This is bound state. Okay. And when you calculate, only one bound state is possible for Dirac function well. Am I right? I think we found the wave function for this one. Obviously, your potential have got a kind of discontinuity, Dirac delta. Okay, that's why again wave function will have some spike kind of shape actually. Psi of x will be equal to some root kappa e power minus kappa mod x, and your energy is equal to minus h bar square kappa square by 2m. Anyone who remembered kappa? I told you should remember this one. They are expecting you to remember directly. What is that kappa? You should remember this one. Just fill out this one. Is that okay? Because they are expecting you to remember that one, some m alpha by h bar square like that, or anyone? Again, I remember the bound state in this way, okay? And again, if you remember kappa, I think that's over. Am I right? Yeah, quickly, anyone remembered?
It's root of minus 2me divided by h cross.
No, I think that is m alpha by h bar square only. That's what I told. Am I right? Kappa is equal to m alpha by h bar square. Is that okay? And you can write your wave function in terms of kappa, E in terms of kappa. That's the best idea. Obviously, energy should be negative. Is that clear? Hmm? So just again, I'm just trying to apply this one. Energy must exceed minimum value of the potential. Again, minimum value of the potential is minus infinity here. That's why E less than 0 exists. Minimum value of the potential is 0 here. That's why energy should exceed that one. That's why E greater than 0. E greater than 0 happen to be scattering state here. This allows only scattering state. This allows both bound state and scattering state. In bound state, it allows only one bound state. That may be the possible question. Okay. Yeah. Any doubts here? Quickly. Yes. You better to. I think 2h bar square would come m alpha by h bar square. That's what I found. Am I right? Yes, that's correct. Okay. You better
Yes, sir.
remember this one. Try to remember. I think if when you substitute this one, you will get some other thing. Okay, some other energy. Try to substitute that one. Okay. I prefer remembering in terms of kappa. This is normalized. Okay. After normalization, I will get root kappa here. Normal, including normalization constant. This is the bound state wave function. You should be able to draw that one also. It will have a spike at x equal to 0. Am I right? E power minus some kappa mod x. It will have a spike, sharp edge. That means first derivative will be discontinuous. Am I right? Again. Yes, let me go to some other question. Any doubts regarding this one? That's why energy must exceed the minimum value of the potential. Okay, that's the main thing that you should remember. Yeah, if there are no questions, I'll just move on to some other problem. One of the very nice problem which will teach you a lot of things. Okay, that is this problem number 2.5. Okay, a particle in the infinite square well. Particle in the infinite square well. He hasn't said what is the region and all, but because he discussed only one type of the potential where v of x is equal to 0 when x is between 0 to a, when x is between 0 to a, it is infinity otherwise. Okay, for that you should know what is the wave function. Psi n of x is equal to including normalization factor root of 2 by a sine of n phi x by a, where n starts from 1, 1, 2, 3 and so on. Obviously your eigenvalues are energy eigenvalues n square pi square h bar square by 2m a square. Okay. 2m a square. Now again what he has given is, again let me try to discuss a lot of concept here, okay, along with this problem. He has given initial wave function. I told in case of quantum mechanics, superposition state is also possible. It's a kind of superposition of two stationary state. We call this one a stationary state. Psi n of x, we call that one a stationary state. Again, this superposition is also possible. Particle can be in psi 1 state, particle can be in psi 2 state. Psi 1 state have got energy E1, particle can be in psi 2 state which has got energy E2, particle can be in the superposition state also. Okay, that is a possibility. That's a quantum mechanical possibility, because superposition of a wave function is also possible solution. It's a property of Schrodinger differential equation. It's a property of linear differential equation actually. Okay, when you linearly combine any solution, that's also possible solution. We state all possible solution of Schrodinger equation is a possible state of the system. That's why it's a kind of superposition state of ground state and first excited state. Okay, first thing is you should normalize that one. There are many ways of normalizing that one. You can again, one thing you should remember, if you normalize at a time t equal to 0, it will stay normalized at later time also. Is that okay? If you normalize at time t equal to 0, again we can show, you can go through Griffiths somewhere in some problem. He has shown that this time derivative equal to 0 using Schrodinger equation. He has shown that one. What do you mean by that one? That normalization integral is independent of time. So that means if you normalize at time t equal to 0, it will stay normalized actually. Okay, that's why you can normalize at psi x comma 0. One way of normalization is this one, minus infinity to plus infinity, mod of psi x comma 0 whole square dx is equal to 1. Am I right? So what is that one? Minus infinity to plus infinity, mod a square into psi 1 star of x plus psi 2 star of x multiplied with psi 1 of x plus psi 2 of x, then you have to integrate. That should be equal to 1. You can do this one, and you can explore that integral of psi 1 star of x into psi 2 of x minus infinity plus infinity. Actually, this integral will go again, will should be rewritten from 0 to a, because outside your wave function is 0. Okay, your wave function exists only between 0 to a. Even though I write the integral minus infinity plus infinity, that integral will be later, it will be converted into 0 to a. Why? Your wave functions are 0 outside 0 to a. Okay, I hope you know that one. So that's why in case of again they are orthogonal. Am I right? Again 0 to a, 0 to a, psi 1 star of x, psi 2 of x dx, that should be equal to 0. Am I right? They are orthogonal. We call this one as orthogonality condition. So that's why you can explore that one and you can solve it. And that's one way. And obviously, I think you get, I think mod a square into 0 to a mod psi 1 square dx plus mod a square into 0 to a mod psi 2 square dx plus two more, which are again, if you use orthogonality factor, they will be 0, that's equal to 1. Obviously these two are 1 and 1. Remember, he will mention that psi 1 and psi 2 are individually normalized already, just like this one. This is normalized, this is the normalization factor. So similarly, psi 1 and psi 2 are individually normalized. That's why this integral and this integral are unity. That's why this will be mod a square plus mod a square, 2 times mod a square, that's equal to 1. A is equal to 1 by root 2. Is that okay? So now look at here. This is one possible way of normalization, and other possibility is, okay, writing psi of x comma 0 in terms of c1 into psi 1 plus c2 into psi 2. There is one more normalization condition that is same as this one. Okay, from this one you can prove this one actually. Okay, that is summation over mod cn square, coefficient mod square, summation over all possible state which appears here, that should be equal to 1. That means, again, if you have wave function like this, a into psi 1 plus a into psi 2, okay, that's your wave function. Now your c1 is a, c2 is also a. So again, what is that one? Mod c1 square plus mod c2 square should be equal to 1. So that means mod a square plus mod a square should be equal to 1. 2 times mod a square, that's equal to 1. A equal to 1 by root 2. So this is the best possible way of normalization, this idea. Okay, how does this idea came actually? Whenever you write this kind of wave function, actually probability of finding the particle in state psi 1 or probability of finding energy E1, that would be mod C1 square. Probability of finding the particle in state psi 2 or probability of finding the particle with energy E2, that will be equal to mod C2 square. If you do the measurement, either you will get this state or this state. Either you will get energy E1 or energy E2 actually. There is only two possibility, either head or tail, isn't it? Then total probability should be equal to 1. Am I right? When you sum up these two possibilities, again, when you sum up these two probability, you should get 1. Why? Again, either you should get this one or you should get this one as the measurement outcome. Okay, that's why again this probability, this normalization comes out of this probabilistic interpretation. You can think like that. or this integral also gives us the same result actually. Just go through Griffiths. Any question here? Remember, in this kind of state, if you do the measurement, remember, if you do the energy measurement, either you will get E1 or you will get E2. Okay, when you get E1, corresponding state will collapse to psi 1. When you get E2, corresponding state will collapse to psi 2. You will not get any mean value. When you do the energy measurement, you will not get any mean value of E1 or E2, E1 and E2. Is that okay? It's just similar to tossing the coin. Either you get head or tail, isn't it? And unless again, now we can just apply this one for, again, you can just make use of what you call electron double slit experiment, isn't it? Single electron double slit experiment. Electron can pass through either slit 1 or slit 2, isn't it? When it is in the superposition state, if you do the measurement, what you observe, you will observe that electron either pass through hole 1 or hole 2. But it is in the superposition state, it will produce some interference pattern if you keep it unobserved. So that's why. So again, these are the measurement outcomes, and these are the probabilities corresponds to each outcome. And according to that one, again, total probability should be equal to 1. That is this normalization condition. Is that okay? Obviously, that also gives us 1 by root 2. Am I right? Now, can I write normalized wave function? Psi of x comma 0, 1 by root 2, psi 1 of x plus psi 2 of x. Now, this is normalized wave function. Now, how do you find psi of x comma t? You should plug in time dependent energy factor. Am I right? Exponential factor. Psi 1 of x into e power minus I e1 t by h bar plus psi 2 of x into e power e power minus I e2 t by h bar. I hope you better to take this one. Okay, your any state can be written like this. Initial state can be written like this in the most general way. Any initial state can be written like this: Cn into psi n, linear combination of stationary state. Again, you can write your later state by just plugging in time dependent factor psi n e power minus I e n t by h bar. For this one, suppose psi n are normalized. For this one, normalization condition is summation over mod Cn square should be equal to 1. Okay, this is your wave function for a later time. You should plug in this respective factor. Is that okay? So that's why this is your time dependent wave function. I hope couple of parts are over here. Okay, normalization is done. Find psi of x comma t and find mod psi x comma t the whole square. Okay, that's the next part. Mod psi x comma t the whole square, that's equal to psi x comma t star into psi x comma t. Okay, again you should use this one. When you do this one, okay, look at here. This psi 1 and psi 2 are real. I hope you know that one. Those are root of 2 by a sine n pi x by a. Am I right? Those are real. So that's why when you do psi 1 star okay, into psi, and again these coefficients are also real. C1 and C2 are also real. Again, you can just write that's equal to, suppose if you are imagining this one as C1 psi 1 C2 psi 2 like that, what you can write here is again 1 by root 2 square into psi 1 of x square plus 1 by root 2 square into psi 2 of x square. I think next term is can you just grab me next term? Some cosine of e2 minus e1 t by h bar into 1 by root 2 square psi 1 psi 2. There is no factor 2 here. C1 square plus C2 square plus I think 2 C1 C2 cos I hope 2 factor would come. Am I right? Factor 2 would come because again you need to manage that cosine, isn't it? You have to divide by 2 and multiply by 2. I hope so. You just cross check later. So if I'm wrong, quickly reply. Okay, that's equal to psi 1 of x square by 2 plus psi 2 of x square by 2. I think 2 by 2 got cancelled plus psi 1 psi 2 cos of what is e2 minus e1. Again, you have energy formula here, isn't it? Again, this is the energy. What is E2 minus E1? E2 minus E1 is, I think, 4 minus 1 pi square h bar square by 2ma square. That's 3 pi square h bar square by 2ma square. That's equal to cos of 3 pi square h bar square by 2ma square into t by h bar. Or you can keep E2 minus E1 t by h bar. You can substitute that one later. Suppose if it is lengthy. Now this is mod psi x comma t the whole square. That is part B of the question. Okay. And again, let omega is equal to pi square h bar by 2ma square. He defined omega. If omega is equal to pi square h bar square by 2ma square, I can write this one as psi 1 square by 2 plus psi 2 square by 2 plus psi 1 psi 2 cos 3 omega t. That's quite simple, isn't it? It looks quite simple. H bar, I think, yeah, I think omega should be defined like this, I think. Not square. Yeah, pi square h bar by 2ma square, okay? Not h bar square. Yes, next part is you should compute expectation x, okay? I may not able to do full part, but let me give you some idea. Minus infinity plus infinity x into mod psi x comma t whole square. Remember, you found expectation x for time t using time dependent wave function. Okay, again, obviously this will turn out to be 0 to a in our case. Okay, now this integral will be, now you should guess some part you should do, some part you can write directly. So 0 to a 1 by 2, okay, x into, let me write psi 1 square as mod psi 1 square, who cares, isn't it, dx plus 1 by 2 0 to a x into mod psi 2 square dx, plus cos of 3 omega t integral 0 to a what is this one, x into psi 1 psi 2 dx. Remember, here this integral will not vanish, you have x here, this is not orthogonality relation, this will not vanish. Now can you guess these two integral? If you remember expectation x for nth stationary state in case of particle in a box, anyone? A by 2, am I right? That is half of the length, because all of your distributions are what you call symmetric about, again, if you take mod psi n square, your mod psi n square are symmetric about the middle of the box. I hope you know that one, am I right? Suppose if I draw those wave function, wait a second, I'm getting some. Yeah, suppose if you draw mod psi square, suppose ground state is this one, mod psi 1 square, which is centered at a by 2. If you take first exact state, if you take square of that one, again it's also, this distribution is also centered at a by 2. That's why if you take average x, actually you will get a by 2, you should get a by 2. Average of the repeated measurement on the identically prepared system, if you take that one, you should get a by 2 actually, because it is 0 to a. So that's why, again, your expectation x for nth state should be a by 2, this integral should be a by 2, this integral should be a by 2, you should remember that one. So that, again, only one integral needed to be solved, a by 4 plus a by 4. Can I write like this? One more 1 by 2 is there, plus cos of 3 omega t, and you need to do this integral. I'm just keeping this part, you just try that one, or if you feel difficult, let me do in the next session. And once you found expectation x, you can find expectation p by Alfred's theorem. What is this one? M into d expectation x by dt. I think that will cover next part. Okay, compute expectation x, compute expectation p, and last question is very important. That will evaluate again what you know about quantum measurement, again measurement in quantum mechanics. if you measure the energy of the particle, what values might you get with what probability? What is the probability of getting each of them? Okay, find the expectation value. Is that okay? Now you may think like that, you may get average of E1 and E2 when you do the measurement. No, it is not like that. When you observe electron in double slit, electron will show off either it will pass through slit 1 or slit 2. It will not show off like that it will cut into half and it will pass through both of the slit. Single electron cannot show off itself as it is passing through both of the slits simultaneously when you observe. When you observe, it will either show off itself as it's passing through slit 1 or slit 2. So similarly, in this kind of what you call superposition state, okay, when you do the measurement, or let me write the state here. What is your state? Normalized state. 1 by root 2 psi 1 of x plus 1 by root 2 psi 2 of x, isn't it? Now, when you do the measurement, when you do the energy measurement, you should get either E1 or E2. Actually, we should not say that we get psi 1 and psi 2. Psi 1 and psi 2 are not observable outcomes, okay? Psi 1 and psi 2 are a kind of a specification of state actually. We say it is in this state, it is in this state and all. Actually, your measurement can be energy only, energy, momentum, position like that. Wave function is not any measuring thing, remember. So that's why you should say, we should say that we are measuring the energy. If you measure the energy, either you should get energy E1 or you should get energy E2. Loosely speaking, we say we get state psi 1, state psi 2 actually, because state corresponds to that particular energy like that, okay? Yes. Now look at here. If you measure the energy, what values might you get? What values might you get? Either you get E1 or you get E2. Either you get head or you get tail. Don't get confusion with measurement outcome with average value. Average value is different. You should do repeated measurement on identically prepared system. You should take identically prepared system, because you can't do repeated measurement on the same system, because each of the measurement is disturbing the system. So that's why you should take identically prepared system, all of which are prepared in this state, and you should do the measurement on each, okay, and then you will get, sometimes you will get E1, sometimes you will get E2, and you should take the average. That is the average value. Again, what is the expectation value? That corresponds to average value of energy. Now, but measurement outcome is different from average. Again, measurement, again, look at here. If you find average, expectation H is nothing but average energy. What would you guess? Either E1 or E2 with probability half and half. Am I right? Because mod psi square is the corresponding probability. Am I right? Suppose probability of getting E1, that's equal to mod of C1 square, that's equal to 1 by 2. Probability of getting E2, that's equal to mod C2 square, that's also 1 by 2. 50-50 probability. You will get either E1 or E2. When you add, you should get 1, obviously. Now, again, your expectation H, or we call it as average energy, loosely speaking, that's nothing but mod of Cn square into En. Am I right? I hope you know that this formula. Average energy or expectation value in case of linear combination state. I call this as linear combination state, okay, or superposition state. Now that's equal to mod C1 square into E1 plus mod C2 square into E2, isn't it? That is nothing but E1 plus E2 by 2. There exists no other C, okay? C3 is 0, C4 is 0. Is that okay? That's why only C1 and C2 exist. That's equal to E1 plus E2 by 2. Average energy is this one. Average of the measurement outcome is this one. But each of the single measurement, that will give either E1 or E2. Any doubts here? Quickly. This is the quantum measurement idea. If you do the measurement, either you will get E1 or you will get E2, but average of the measurement, obviously, if you have 50-50 probability of getting E1 and E2, average will be mean value of E1 and E2. You can expect like that. But you will never get again, single measurement will never give this result. Is that okay? Or electron will never show off itself as it is cutting into half and passing through both of the slit. It will show itself as either it will pass through slit 1 or it will pass through slit 2. Yeah, any question quickly? So try to solve this question fully, so that again lot of aspect that you will understand here. Again, in part D, he is expecting you to use this formula: expectation P is equal to m into d expectation x by dt. Again, you can use one more formula for P cap. Am I right? What is this one? Integral psi star minus I h bar dou by dou x into psi ds. You can make use of this one also, but that is quite lengthy. That's why again, anyway you found expectation x, take time derivative, you will get expectation P. That's what he is expecting. Yeah. So quickly, any questions? Yeah. Again, I'm just addressing YouTube subscribers. If you have any doubt regarding any problem in Griffiths quantum mechanics, you can just send me via email, so that again in the next session I can solve it, or I'm going to choose my own problem. Okay, in the next session I'm going to tell you again what are the problem that I'm going to solve, so that you can just what you call uh, yes, yes, tell me. Yes, tell me, any doubts?
Sir,
Yes, tell me. Actually, we can't hear you properly. Viswarajan, are you there? Yes, tell me.
I'm
No, your voice is not continuously coming. Yeah, do one thing. Why can't you? Okay, what shall we do? Yeah. Oh, so why can't you send the doubt, and then later in the tomorrow's 5 o'clock class we shall discuss that one. Is that okay? Yeah. Again, I found very less question, and it's quite sad that again you should develop again those kind of attitude. Okay, attitude of asking the question, because once you ask the question, again if I reply, that concept will be very clear for you. Okay, again I'm keeping this platform very open. Again, you can send your question to snbose plg@gmail.com. Or if you are watching YouTube video, you can just type doubt in the comment session, in the chat box of that YouTube video, so that I can reply. Okay. Yeah. So Viswaranjan, you better to ask. Yes. Can
Sir, am I audible now?
yes. Now you are audible. Yes, tell me.
Sir, I was asking about the problems in which the wall expanding to 2 times, 4 times, or it suddenly is sinking to half times. How to deal those types of problems? Could you explain in your next class?
Okay. Let me take that kind of problem tomorrow. Okay. I think in Griffiths also he mentioned that kind of problem. Again, that's also again writing your final state on which you are doing the measurement. Again, I take one universal rule. Am I right? The state on which you are doing the measurement should be expanded as linear combination of eigenstate of measuring operator. If you are measuring energy, you should write that one as linear combination of energy eigenstate. Then coefficient mod square will give you the answer. That is one possible way of explaining. Other possibility is inner product between initial state and final state, that will give you the probability amplitude, isn't it? Yeah, let me take that kind of problem. Okay, I think I better take some problem from Berkeley or Princeton problem. There are many problem like you, so like what you told. Okay. And I'll give you much more
Okay, sir.
logical idea over there. Actually, uh, f- uh, uh, again, any state can be written as a linear combination of eigenstate of Hamiltonian operator. Again, our Fourier analysis will ensure us actually. Your eigenstates are sine functions. Am I right here? You should do some Fourier analysis in order to understand this one. When you see eigenfunction, again those are signs like this. Am I right? That's why any function can be written in terms of sign. Again, your Fourier theorem will ensure us that we can do like that. So that's why again after expansion you will have new box, you will have new Hamiltonian. You should write your initial wave function as a linear combination of final wave function actually. And that coefficient is nothing but a kind of inner product between initial and final. We shall see that one. Okay, how to grab those ideas. Okay, in the next session I'll just talk about that inner product and that problem. That's a good idea.
Sir,
Yes.
I have another doubt.
Yeah.
Hello.
Yes, tell me.
Sir, in case of that symmetric apparent means the problem when the box length should be taken from minus a to plus instead of
Okay.
minus a by 2 plus a by 2 instead of 0 to a. That kind of problem can.
Hmm. Now minus a by 2 to plus a by 2. If box is from minus a by 2 to plus a by 2, suppose if box is from 0 to a, your wave function is root of 2 by a sine n pi x by a. Am I right? If box is from minus a by 2 to plus a by 2, box length is same, energy will not change. Okay, En is same here. Okay, En is same in both sides because energy depends only on the length of the box. That's a. Now again you should change x by x plus a by 2. N pi x plus a by 2 n pi x by a. Is that okay? So this happened to be root of 2 by a. I think cosine of n pi x by a when en is I think 1, 3, 5 and so on. That will be root of 2 by a sine of n pi x by a when n is equal to 2, 4, 6 and so on. Is that okay? This is the new wave
So
function.
I
Wave
think
function means, yes, tell me.
so I think even functions are taken as cosines and odd ones are taken as sines.
Ground state should be cosine. Am I right? Ground state means n equal to 1. That's how I remember.
Yes, sir. Yes.
Isn't it? Ground state means n equal to 1. That should be cosine. Why at x equal to 0? Your wave function should be non-zero. Remember, shape of the wave functions are same as box from 0 to a. They will not change. I think this is not like this. This should be mod psi square will not change. Okay. I think this. So this will be like this. Mod psi square will not change. Is that okay? So only okay. That's why again this should be cosine function. Ground state should be cosine function. Am I right about this one? I hope
Yes,
I'm
yes.
right.
This is right.
Again, this is how the changes that you should do. Okay, you should change x by x plus a by 2 because you are moving a kind of curve is shifted backward. Okay, when you just observe from here to here 0 to a. Okay, this was your wave function. Now what happened is minus a by 2 to plus a by 2. It's a kind of curve is shifted backward. Am I right? Again, this is your origin. Now this is your origin. Your curve is shifted backward. That's why x should be changed by x plus a by 2. Again, you will get new wave function, but energy is remains same. Okay, energy doesn't depend on choice of what you call origin. Actually, it depends only on the physical parameter, just like length of the box. Is that clear?